These are our pre-calculus notes. We are in section 6.1, and that is multivariable linear systems and row operations, which sounds really scary. So we start out with a little bit of vocabulary. There are different methods for solving systems of equations, and we're going to kind of look at some of those today. So it's important to remember we're still just solving systems, and we're looking at primarily systems of three equations, but we're going to just have some different tools to do that. So the first method is this Gaussian elimination. So Gaussian elimination is when we get our system in this form. So we get system of equations in this form. And then solve with back substitution. So back substitution is what we have done all along. You actually know what that is. So back substitution, once I have z, then I put z into the previous equation, and then I solve for y, and then once I have y, we put them both into the first equation, we find x. So basically this form is called row echelon form. And I always point out that it makes kind of a nice fancy triangle. And the other thing that we notice is the first row has a 1x, the second row has a 1y, and the third row has a 1z. And you'll see that I'm calling them, instead of equations, I'm referring to them as rows. And that's because we're going to be taking systems of equations and actually putting them into matrix form today. So instead of looking at equation 1, 2, and 3, we're going to be thinking about row 1, 2, and 3. So I'm already kind of using that vocab. So the big thing for this row echelon form is my first equation, I have a 1x, and then it's okay to have y and z. My second row, I don't have any x's, so there's 0 x's, but I have 1y. And I can't have a 2y or a 3y. It needs to be a 1y. And then it's still okay to have z. And then in my third equation, I don't have any x, I don't have any y, I only have z. So our leading coefficients are all 1. And each row has less variables than the one before. So that is that row echelon form. So Gaussian elimination is going to be changing a system to this form and then solving with back substitution. And we could do this in a matrix or without. Your math book has us doing this without. So that's what we're going to do here. So we're going to first just practice this. So I want to take this system and I want to write it in that triangular form, which is the row echelon form, using Gaussian substitution. Or Gaussian elimination, sorry. That's how I'm going to solve it. So in order to put it in this form, I can follow those same rules that I always did for elimination. I can interchange any two equations. So I can take like equation 2 and equation 1 and flip them if I want to. I can multiply by a number, and I can add multiples of one equation to another. So notice, just like before, I am saying no subtraction. Your book is saying no subtraction. We can add negatives, but we never want to do subtraction because we screw it up. We're going to be really specific with the way we're showing our work so we can keep track of what's going on. So when I am looking at the system, I notice that I have a 1x, which is really good. My first equation is all set. But I can see that in my second two, I have a 3x and I have a 2x in those other rows. So I always work from left to right. I really want to get rid of those x's. I need to have 0x in the second two rows. And so because those are the things I'm getting rid of, I'm going to work to get a new row 2. And so I'm going to put like a little star here, and I want to work to get rid of this row. So in order to cancel out the 3x in that row, so I say get rid of it, but I really mean like make a new row 2 and replace it. So in order to get rid of that 3x, I'm going to have to do some work. So I am going to multiply, and here's my 1 star, because that's what this is for, right? Fixing that row, is I want to multiply -3 times my first row, and then I'm going to add my second row. So I'm being really specific about what work I'm doing, and the reason that I put the star there is because I'm getting a new row 2. And this is what I'm doing. I'm doing -3 of row 1 plus row 2. So let's go through and multiply the first row by -3. That gives us a -3x minus a 9y minus 6z equals -15. And then I want to copy down row 2 the way it is. And then we're going to add them together. So x's are gone. We have a -8y minus 8z equals -8. And then I know I can multiply equations all the way through by something. So I'm going to multiply this one by -1/8, because then I'll just have a 1y plus a 1z equals 1. So easier to work with. So I've got my row 2 all fixed up. It starts with a 1 and I don't have any x. So that's really good. So now I want to work with my last row. I want to work with row 3. And I want to cancel out the x in that row as well. So we're always looking from left to right. So I'm first looking right now in just that first column, and I want to have a 1 here, but I want the 3x and the 2x, I want those to both be gone. So that means I'm going to put some double star over here because that's what I'm doing. Normally I would work down my page, but for working on my computer that I have, it's going to make more sense for me to go across. But if I were you, I'd be working down right now. So I'm going to have to take and use my row 3. And I want to cancel out the x, so I'm going to do plus -2 row 1. And I could have reversed the order on that. It doesn't really matter, right? All that I'm saying is whatever answer I get out of this, that's going to go for my new row 3. So row 3 is 2x plus 2y plus 3z equals 3. And then -2 times row 1 would be -2x minus 6y minus, I almost did that one wrong, minus 4z equals -10. And then we want to go ahead and add, and our x's cancel like we planned on. So -4y minus z equals a -7. Okay, so once we have replaced, we really have fixed up a new row 2 and a new row 3. Row 1 we're leaving, so now we're going to write our new matrix. So, oh, sorry, and I said matrix, but we're doing matrices later on. Right now we're just looking at systems. We're kind of breaking you guys in gently. I'm going to put a bracket here to show that the 3 go together. So my first one's not changing, x plus 3y plus 2z equals 5. My middle one's good. My middle one is y plus z equals 1. And my last one is -4y minus z equals -7. Okay, so we always look in columns. So my first column is perfect. I have an x in my first equation, but not in my second 2 rows. My second column is the one I need to work with. It's okay to have a y here in my first row. It's okay to have a y in my second row, but I don't want this y to be here in the third row. So that's what I want to cancel. So I'm going to go ahead and put a little star there. And in order to cancel that -4y, it's going to be easiest to combine it with row 2. So I'm going to want to do and put 1 star because this is the work I'm doing is for this star, and it's going to go in that row 3 position. So now I'm going to take and do 4 times row 2, and then I'm going to add row 3. So let's go ahead and move this up so we have a little bit of space. So let's see, that would give me a 4y plus 4z equals 4. And then the other one, let's see, is a -4y minus z equals -7. And we want to add those together. And we get 3z equals -3. And then, of course, we'll multiply that by a third so that we have a 1z instead. And z will equal -1. So now that I have fixed my third equation, I can come up with my system, right? So my first one is x plus 3y plus 2z equals 5. And this is Gaussian elimination. Gaussian is when we want to have that triangle. We'll show the triangle in just a second. Second one is y plus z equals 1. And the third one is z equals -1. So you can see I kind of wrote my values here so that they followed that kind of triangle, like I gave space there. I guess I don't really want to make my triangle up across the equal sign, but you can see where they make a triangle. And I have the 1x and the 1y and the 1z. So my second row has no x's. My third row has no x's or y's. So now I'm going to finish this off using my back substitution. So back substitution is I take my z and then I go back into my row 2 and find my y. So y plus c equals 1. So y plus -1 equals 1. So y equals 2. And then I'm going to take both z and y and substitute back into the third equation, into the first equation and get my x. So x plus 3 times 2 plus 2 times -1 equals 5. I didn't know if I'd be able to fit it in, but I did. So x plus 6 minus 2 equals 5. X plus 4 equals 5. So x equals 1. We still want to write our our solutions together. When we had ordered pairs, we did x comma y, and since we have 3 here, we need an x, y, z, and ordered triple. So we don't have a pair, we have 3, and it'll be 1, comma, 2, comma, negative 1. So there's our answer. So we use Gaussian elimination. So we had that like triangle value things going on, and then we used back substitution to find our final answer. So this was the back substitution part. And then Gaussian elimination was getting it into this triangle, which is that row echelon form. So just kind of overviewing vocab again there. So we could also have done this in matrix form. So keep that in mind as we go through our examples, that we can do Gaussian elimination using a matrix as well. So I'm going to go ahead and scroll this up, and we're going to look a little bit more at vocab. We're not going to do too much more on this first video. I want to have my videos separated out so you could look at just Gaussian elimination or just Gauss-Jordan. So the second part, or second example here, is we're just looking at some more vocab, and I have a system of equations right here, and then we're looking at changing that into matrix form. So to change it in matrix form, what I'm basically doing is I'm looking at these coefficients, and I am just going to have like my x's in my first column, and then my y's, and then my z's. And so I just take my coefficients and I write those down without x, y, and z. So it's understood that that's what they stand for. And then we have this, they show a dash line. I just make mine solid because it's a lot of work to do a dash line, but my answers are on the other side of that. So it's just a way to separate out what they're equal to. So this is that augmented matrix. So coefficient matrix is just coefficients only, no answers. So coefficients, that is not the correct spelling. So this is coefficients only with no answers. So there is a considerable amount of your homework just devoted to changing things back and forth from your augmented matrix to your system of equations. I don't think it's too hard. I think that'll be pretty easy for you. So that's what we're going to practice on too here. So I always want to look over what my variables are. If I look at the first row, I see x, y, and z, but then I notice in the second one I have a w. So I have to figure out our variables, and those columns should always be in alphabetical order. So that means we would have w, and then x, and then y, and then z, and then we'll have that line, and then we'll have our answers. So that's how we're going to set it up. And each equation will give us a row. So in my first row, because I don't have a w, I'm going to put a 0 here as a placeholder, and then a 1, 1, negative 1, and then we'll have a 5. In my second row, I do have a w and I have an x, but no y, so the y column is going to get a 0. So we're just taking our equations and we're making like a number grid. So that's what we talked about during class today, is that augmented matrix, all of these words can sound kind of scary. I can see I got a typo right there, but we are just really trying to get this into a number grid so that we don't have to write down x, y, and z every single time. So remember, the whole point of what we're doing today is just more tools for solving equations. So we are systems of equations. So that's all we're really doing. That's the heart of what we're doing today. So row echelon form. So this is basically what we did before. We looked at row echelon form, but we had it not in a matrix. Now this is row echelon form in a matrix. So basically the same thing. We still have that triangle of values, but now it's in a matrix instead of with the x and the y and the z. So rows that are zeros are at the bottom. We always start with ones, and they make that triangle where you wouldn't have like the second and the third equations mixed around. We want them to be able to go down like that. So we're going to just decide if each of them for number 3 are in this form or not. And then I'm actually going to stop the video and we'll do Gauss-Jordan elimination in the next video. So I want to look at, do they make this triangle? They do. I have a 1 and then a number. That's cool. We don't care. And so the first one's going to be yes. The second one, I have a row of zeros in the middle, which should be at the bottom. Should be at the end. And since it's not at the end, let's say bottom. It should be row 4. Then this one's going to be no. The next one, I do have the row of zeros, but it's at the very bottom like it's supposed to. And the other 2 rows make a triangle. So this one is yes. So this is the end of our first part of the notes. This was just looking at Gaussian elimination and then putting things into a matrix form. So with the next video, we will look at Gauss-Jordan elimination, and we'll do a few more examples. That's where it starts to get more difficult.